Good afternoon, everyone. Thank you so much for coming to NDC London and for coming to my talk specifically. We know we're in the last time slot of the day. People are probably getting tired. Hopefully we're going to keep this fun, we're going to keep this interesting and get on to the party and the beer. Right? Yes. This talk is hostile JavaScript, attacking and defending the browser. And this is a bit of a new space for me. Normally I work in web monitoring, client-side observability stuff. I have never really dabbled in the security space before, but it's always been super interesting. There's been a bunch of really cool people that I've looked up to, and I think I can really have something interesting to add to the conversation. And so that's what I'm trying to do here today. So what I want to talk about with you is, one, just some general ideas, some fun ways of how people attack web browsers with JavaScript today. Then we're going to look at the various vectors. I'm not a security guy again, so I don't know if I'm using that word correctly, but if you go to a security conference, they use terms like vector and exploit, so I'm just going to adopt the vocabulary and hope that I'm using it correctly. So vectors that we can use to put new JavaScript into the browser, and then some ways to defend the browser from JavaScript, because JavaScript. To do that, I built a little website. I built a little website as a playground, and I want to show it to you all. It's Todd's GeoCity fan site. Who here had a GeoCity site? GeoCity sites were amazing. You'd build fan sites for whatever you were into at the time. Well, I'm a fan of GeoCities, so I built a GeoCities fan site. And it's got all the best things. It's got fuchsia fonts, or fuchsia colored titles, Comic Sans, super pixelated bricky logos. Like all GeoCities sites, constantly under construction. They were never done. We got to have some dancing babies in there. You had to. And early analytics. We had, visitor counters or whatever. But I got to make some money off of this. I'm not doing this for free. I got to buy beer and pay rent. So I'm going to put some ads on here. Here's some old school 90s ads. Pizza Hut all over the internet way before their time with GIF-based banner ads. And I think that's probably good for me. But to build this site, I needed JavaScript. And I probably had to bring in a bunch of different things. So I would have my own JavaScript, my scripts.js for the stuff I wanted to do, hosted on GeoCities or wherever. Of course, I need jQuery, because you got to have jQuery. And then I have this thing from a counter to get my elite visitor counter in the corner. And for placing the ad, I need some sort of terrible ad bidding system. And so just with this super simple site, I'm already pulling in JavaScript from 4 different domains. But then my marketing team gets its hands on it, and they want to add way more stuff with Google Tag Manager. Because tag managers are this nasty back door that we give people outside of our engineering organizations the ability to put JavaScript on our page without even checking that it builds correctly or doesn't do terrible things. So my marketing team got all over this, and they started thinking, you know what this site needs more of? It needs more ads. So let's put a couple more ads. Again, Pizza Hut's just all over this. You can never have too much analytics, so let's add a couple more visitor counters. And by the time we get all that done, now we have a bunch more domains that we're loading JavaScript from. So now we're pulling in Google Tag Manager and DoubleClick and some cool trackers from various different places. If you want to check this out, this is real. So there's the code, or I can't believe this is available, I bought geocities.website. So it is on there right now. It is this super cool site. You can go out there and you can see those dancing babies, and there's a little text box where you can type in what your favorite part of the early internet was. So go ahead and play with it while we're going through this, because it's going to come back to bite us later, and we're going to show how we're going to exploit that site. So first, how do we attack our sites with JavaScript? Well, the first way, kind of a boring way, but super widespread, is if we can get our JavaScript into somebody else's website, we can consume the resources of their computer or the attention of their users to make money. And obviously, that's through ads. If you can make money by putting ads on your website, I could make money by putting ads on your website. So if I can run JavaScript on your page, I can put my own ads, I can overwrite your ads, I can add a bunch of new ads, and then I can make a bunch of money off of it. Or, more recently, there's all kinds of fun ways I can inject crypto miners directly into your website and have all of your users mine cryptocurrency for me and just slowly heat up their phones until they're burning hot because I've consumed every resource on that phone and its entire battery. And so once that's done, there's a bunch more ads on the page, which is super fun. How else could we attack it? Well, we could compromise the users. Once we're on the page, we could steal information from the user directly. So I could pop a pop-up, or I could open something up that looks a lot like a login page, because this is what a login page would look like on my GeoCities site, right? That's totally what it would look like. And just try and scrape the username and passwords from my users. Or pop open bad images, thanks PowerPoint. Pop open images to like Google or Facebook or other login services and try and get that sort of stuff. But that's super boring. That's super, I mean, they can probably make a lot of money and scrape a lot of credentials that way, but it's just super boring. It's not interesting. So what I really want to talk about are ways that we can steal data from the users using two different kind of JavaScript techniques, and then what kind of havoc that we can wreak when we do that. And so the first, we can keylog. So we can capture all of the keystrokes that the user is entering while they're on your website. Not just interactions like anything that they're doing on the page. And this is relatively easy to do with JavaScript. So if you're not familiar, we're actually going to do a demo right now for how this works. Let me make sure that it actually pops up on the screen when I change over. I'm on the wrong thing. There we go. So if I wanted to set up a keylogger, I can listen at the document level to a well-established event called keyUp and log it out, send it off to my API whenever it happens. So if I just enter this in and then start interacting with my page, every key I type, we could cache or batch that up, send it off, and that way I can capture any form input, I can capture any interaction the user might have on the page. I could get more clever about it and capture whole inputs together by listening to different events. Here is an example of, let's reload and try this again. I could also listen to the blur event at the document level. By listening at the top level of the page, I don't need to know anything about your page. I don't need to know how your forms work, what it looks like, anything at all. I just listen at the topmost level of your page for when these events go off, capture that data, and send it off for my own nefarious purposes. So if I listen to blur, which is an event that happens whenever you move focus off of a input field, and then enter, my favorite part of 90s internet was the blink tag. It captures exactly what I entered and posts it off. This could be my credit card field, it could be my username, it could be my password, it could be anything I'm doing off the site. Once I get the JavaScript on the page, I can do anything. I can capture any data that I want from that user and their interaction. Once I do that, I can take that data and send it off to my own API. So my user hanging out, doing fun things on Todd's GeoCities fan site, and as they interact and give me a credit card number for this awesome service that I'm providing, I can just copy that data off and post it to my keylogger endpoint for me to do whatever I want, sell that credit card number, whatever. A much more fun so I'm a JavaScript nerd. I like low-level JavaScript stuff. So I just every time I have a chance, I talk about monkey patching. Who knows what monkey patching is? Just a few people. Not a lot of JavaScript nerds here. All right, monkey patching is the greatest word ever. I can just change the behavior of built-in functions of JavaScript. The native functions aren't like sacred and holy. I can just say, hey, add event listener. You don't do that anymore. Now you do this thing that I just told you, whatever. Here's an example of how that works. So if I don't want to be, if I don't want to listen to key input, let's say that relies on the user to actually do something on the page. A lot of pages will do all kinds of interesting requests all by themselves. Ooh. For example, if I have a web page, and as part of like setting up that page, it makes a bunch of fetch calls. It pulls data from my API, it goes and gets something, or it posts juicy data that I want to steal off to its API. You'll use a post, and that will send a whole bunch of different data out. Now, I can capture that using a practice called monkey patching. What that lets me do, obviously I do not trust the demo gods at all, because I have these all pre-canned and ready. Fetch is that method that I can make AJAX calls from. I can make network calls from the browser. Well, that's not a sacred function either. I can just redefine what fetch does for my own nefarious activities. I take a copy of the authoritative fetch function, which is on self or window. I grab it, and then I just redefine fetch to be my own function, where I could send data elsewhere. In this case, I'm just piping it out to the console so that we can see it, and then I'm calling through to the original fetch function so that everything looks like it's operating. But I've essentially instrumented the entire app to clone all of the data that is sent to or from this browser. And so if I execute this patch, or this monkey patch, and then execute my post call, it still executes the post, and the application will do as we would expect, but I also got a copy of that data. I piped it out to console.warn and got a copy of it that I could do whatever I want with. What this would allow us to do is your application, as it's humming along, doing its thing, the user maybe is interacting, maybe it's pulling data, maybe it's polling your service. But every time that data comes in, if I can put JavaScript on the page, I could clone all of that data. I could just make a copy of your entire system slowly as the users are interacting with it. And all I need to do that is be able to execute any amount of JavaScript on your page. That is kind of one of the mechanisms of one of the scariest browser exploits that's come out in recent times. Now, this isn't actually new. Like, this kind of concept has been happening for a long time. Who's heard of MageCart? A lot of people. More people have heard of MageCart than have heard of monkey patching. This is weird for me. I talk about JavaScript, and so this is weird to be talking to a security audience. This isn't actually all that new. This is, I can inject JavaScript on the page, and then I'm taking copies of it. MageCart essentially gave ways of, once I got JavaScript on the page, I'm going to look for credit card forms, and I'm going to take the data that's entered in those credit card forms and post it off so I can sell those credit cards. And that's all it was. Now, most of those exploits there have been over 70,000 stores compromised by MageCart. Now, most of those came from like non-client side vulnerabilities. So they came from like somebody was able to do like some sort of script code execution on the servers, compromising Magneto or whatever, Magento. I don't know, I'm not an e-commerce guy. Compromising other things in that and taking over, being able to change the shopping cart functionality and inject other code. But it also happened through product reviews. So being able to inject a cross-site scripting vulnerability as a review of a product, and now I have JavaScript on the page, and I can clone it. These aren't just fun toys. Like, there's real stuff in it. As I was putting together this talk, and I was talking to some security people about it, they're like, oh, you're talking about beef. And I was like, what? I've never even heard of this thing. And this is super cool. This is the browser exploit execution framework. And it allows us to basically inject all kinds of different typed exploits into a network and take over browsers and then do this to them. Capture keys, capture forms, implement monkey patching even if you don't know anything at all about JavaScript, enabling lots of people to do terrible, terrible things, like an active attack. Like if I want to go after specifically Todd's GeoCities fan site, Using a tool that would allow me to connect like Beef, I could not only capture all of the network calls that are being made by my site passively, but I could use the session of a particular user to scrape your API. If I was after you, like I'm after you, I want your data in your API. If I can compromise one of your users, I can use that user as a tunnel and their credentials, their session, to query and pull data from the rest of your system and just suck it out through their browser. There's all kinds of cool, scary things that they can do. Let's talk about some vectors of ways that JavaScript can get in. Because hopefully you're all like, that's some, you have access to the browser, you can do anything you want, Todd. But you're not going to get access to the browser. How does that happen? There's lots of ways that happens. The first is through traditional exploits. So all of the same things that you're already probably worried about on all of your servers. If I can gain any sort of control of your web server, I can change what your web server does to put my JavaScript on the page. So code injection attacks in all of their varieties. Or cross-site scripting attacks, which if we were web developers, we're probably doing this all the time, pasting basically this string into every possible input to see where our system might fall over. And hopefully that alert never pops up as you're playing around. Because we need to sanitize our inputs and make sure that we're not putting executable JavaScript in our field. What's more interesting and more scary, because it's harder to control, are supply chain attacks. Who's ever worked with a supply chain attack or thought about this? A few people. So when you're building your web app and you need a dependency, and you're like, oh, I'm going to pull in left pad. I don't want to figure out how to pad out this number. I'm going to pull in this trivial package to do it for me instead. So I npm install left pad. Do you look at the code that just came down? Do you go into node modules and see how does this actually work and does this do anything? No, of course. Practically, we say we do, right? But if you do npm install express or npm install react, 15 bajillion lines of code just got downloaded, and none of us are reviewing that. And that's the problem of a supply chain attack, is anywhere in that code, there could be magecart. There could be some exploit code that maybe is weird minified in hexadecimal characters to only activate on Todd's GeoCities website, because that's who they're targeting. And if it's ever loaded on Todd's GeoCities website, turn on and start scraping credit card numbers. Because it's a targeted attack coming from the supply chain. This is not fictional. There was a whole bunch of cases of NPM packages being compromised, not even really compromised, a series of problems called icon burst, which was trying to exploit typos, just typos. You wanted some icons for your Ionic project, or you wanted to pull in a font awesome pack, but you didn't want to bother going to fontawesome.com. You just naively went to npm and said, npm install font awesome, but you typoed it. Well, somebody squatted on that and sent it to you anyway. And thousands of these packages, which are just typo squats with malicious code in them. They'll still give you your cool font awesome icons. But while they're at it, they're also injecting an exploit. And you never even thought about it. You're just like, oh yeah, I trust font awesome. I trust Ionic utils. I trust whatever. You don't look to see did I spell that correctly? That's what's terrifying, because I misspell things all the time. I am a terrible speller. And I don't review all the code that comes down in NPM. So this could have happened to me. How do we know when this even happens? Another interesting thing that I think about a lot, maybe not a lot of other people think about, but I put a lot of JavaScript on people's pages. I put a lot of JavaScript on other people's pages. I built a service a while ago called Track.js that does error logging. Tracks a bunch of things about what's going on our users' pages so I can tell them about errors and stuff like that. And the weird thing about Track.js is that we've been operating for about 10 years. And I would say For every one of our customers that's paid us and used us, there's probably 50 or 100 people that tried us out, they put us on their domain, and then it didn't work out for whatever reason. A lot of them still have my agent on their page, years later, from domains that are really credible and big and should know better, but they just threw my JavaScript on their page, and it still have it years later. Which is interesting for me, because I can see data coming in from all kinds of people, and I'm not a malicious actor. So you could argue that, like, yeah, that's not really a vector, because there's a static nature to what you're doing, Todd. Like, this is one agent, it does this thing, and there's, like, legal agreements in place that trust me to be a good actor. I'm like, fine, I mean, there is. If you were to build a service, though, that instead of just doing one thing, like catching errors, but like maybe would allow the user to do all kinds of dynamic things. Like if I had a service that allowed whoever was using my script to enter commands and do things with it, and maybe be totally anonymous with where the data goes and who can see it, and allow users to remote control what's going on the other side, that could be a service that gets kind of dangerous. And I kind of accidentally built one of those. I didn't know it at the time, but it kind of turned into cross-site scripting as a service. The core idea of it was like, hey, we have this Track.js product. It's really cool. It allows people to debug things. It'd be awesome if I could do that in like real time. Like, what if I could connect to one particular user? I have a problem device. It's a weird browser client. It's a set-top box or an old Android. I want to connect to that one and see what that thing is doing. And then maybe I even want to interrogate it. I want to send commands and see what the state of it is when something happens. And so that's cool and useful. And a lot of people used it. It's still in widespread use today. For a lot of like hotel set-top boxes that run web clients in order to like help you connect to your Netflix account when you're traveling and stuff like that. So it's super useful. Unfortunately, a lot of the people who are on the internet don't know how the internet works and would go ahead and install this thing and then just deploy it to all of their production sites. In some case, healthcare-related production sites or shopping, credit card related public sites. Things that should not have cross-site scripting as a service, and I'm not sure how they get away with doing it. There's another site that put this on their page and deployed it pretty widespread. Todd's GeoCities fan site deployed it and put it on. I'm going to show you how terrifying this is. So if you're not already, open it back up. Open up Todd's GeoCities fan site back up. And if you'd like, pop in a comment about what you thought the best thing about the early internet was. And I can look at the other side of Remote.js. What Remote.js let us do is there's that little agent that runs in the code, basically set up a WebSocket connection back to me, back to my browser. And I can connect and see, here's all of the different agents, here's all of the different browsers that are looking at that page right now. And I can connect to one. So like, who's using Opera Touch 2.9 on Android? I have no idea if this is even going to work, but we're going to try this. We're going to connect to that session. And let's see what their page looks like. I hope this even works in Opera. It does work in Opera. Can't really fit, it's super big. Todd's GeoCities fan site, under construction. What was the most awesome thing? Me.
Get back up. Get out. Did your browser not have marquee tags?
No, marquee tags aren't supported.
Oh, it works on mine.
So this is just a static, there's probably a cross-site scripting vulnerability in that, honestly. But even better, I can not only see what's going on, I can interact with her browser. So I could say, I can send an alert command that pops up on her. I have a direct connection to her window, I can see everything that she does. I could inject keyloggers. I could scrape data. If she had a session, say this wasn't a silly website. Say this was a healthcare provider website. I could utilize that healthcare provider's session through Remote.js or through any sort of cross-site scripting related connection to just scrape all of the healthcare related data through their session and just pull it back. That's terrifying. I had no idea that people would do this until I went and accidentally built cross-site scripting as a service. So yeah, there's a whole bunch of you connected right now. I think the UI is just limiting it to 10 because, you know, I'd probably have way more tools. If this was malicious, I'd probably have way more tools to filter down and identify a user session. But I was really never expecting this to get used by any more than like 2 or 3 people at a time. So between Remote.js and then my experience with Track.js, running it and seeing how much data comes at us from people who never pay us, leads me to this conclusion that most websites, most of us as web developers, if we look at our production environments of the real systems that we care about, we have no idea what JavaScript is running on it. We just paste whatever thing we think is useful, whatever marketing tag our analytics team wants to put on it, whatever useful thing that we ran across, we just paste it in, it's whatever, put it in the head, it's good. And then we never think about it again. Even if it's referencing a site from a different domain that like could change at any time and we have no control over when they change their code. And that's a terrifying prospect. I don't know how the internet still works with how bad that could be. And so I've been thinking a lot about how do we go about defending the browser from these sort of things. And there's some established ways that we can do this, and there's some weird ways that we can do this. The first begrudging thing I need to tell all of us, even myself, because I need to do it too, is that we have to review our dependencies. It sucks. I hate it. I do not want to look at 5 bajillion lines of code that come down when I say npm install React. But we probably should do it sometimes, at least for packages that we don't like trust. And maybe we should check for typos. Make sure, did I spell React right? Is that the right directory that showed up in npm in node modules? Is it correctly spelled there? That's boring. Like, it's not very fun to be like, you got to review all your stuff to make sure you're not going to get hacked. That's a terrible piece of advice. I just have to, begrudgingly say it. The authoritative way that security people want us to solve it is through content security policy. So HTTP-based rules that we define on our page and say, here's what our page is and is not allowed to do. And that's all super cool. And that's been around for a bunch of years, and it's super well supported. Content security policy, in theory, looks like this. It's a little header you put on your page, and you define something super secure like, I only want to run JavaScript from my domain, and nobody else. And it's going to be secure, and it's going to work great, and everything is perfect. But in practice, once we actually put this on real sites that need to do real things, we start with that. And then marketing says, well, yeah, but you got to give us Google Tag Manager. Like, you can't not give us that. And then, oh, we're going to install some tracking pixels. And we're going to install some more tracking pixels, and like 21 more things. Oh, and then I also need scripts from Track.js. Oh, and then I just want to be able to load images from anywhere. Just don't even restrict me. And by the time we're done, like, this thing is huge, and it's changing. And every other day, somebody is requesting us to add something else. And it becomes very difficult to manage, very difficult to maintain. Are you reviewing every one of these domains as you're adding it? Or does it just become another chore of, like, we ultimately just are npm installing whatever domain we wanted to put in it? Ultimately, you should use content security policy, especially if you have a high-risk environment. If you are in healthcare, if you are a high-volume retailer, if you have data that you are very, very concerned about, you should use content security policy. There's a gentleman here in the audience who builds this awesome tool for that called Report URI, which allows you to, like, capture all of that data without having to build without having to build any of that sort of stuff yourself. So you'll get all the reports about when your pages have violated the policy that you set out. Unfortunately, for most of us, we don't implement content security policy. And this is, this has been talked about a lot for many years, but it's just not getting well adopted. Less than 14% of all pages have it, less than 10% of subdomains as of last year, a widespread report. It's just not getting implemented to the degree that it needs to be. And it's kind of because it's technologically hard. It's a hard thing to do. It's like sits in this weird domain kind of halfway between DevOps people and application people and security people, and nobody's really sure who owns it or who maintains it. It's just a weird place to be. Kind of a related technology to that is sub-resource integrity. If I'm pointing my JavaScript at a domain, that domain could like change what that JavaScript is over time. Like if I'm pointing at js.stripe.com, stripe.js, Stripe can change the content of that JavaScript file whenever they want, because we're just pointing at it. Now, in Stripe's case, we probably trust them, because they're Stripe, and they're handling all the credit cards of all of us, frankly. But when you point at that one-off CDN, do you trust them? Do you trust them not to change the contents? Do you trust whatever CDN not to like put something in their version of jQuery or React or whatever you're hosting from them? Because they can change it whenever they want, unless you use something like sub-resource integrity. What this allows us to do is something like this, where if we're pointing at a domain and saying, hey, I want to load scripts.js from whatever, I generate a hash, or I can get a hash of what the content of that file is. And then if the contents of the file that the browser downloaded don't match, the browser will not execute it. It will not allow the user to, or it will not allow the script to be executed at all. Unfortunately, there's two big problems with this. The first problem is sometimes we need to let that other user change it. In the case of Stripe, you have to let them change it. That's part of their policy. They need to be able to fix stuff really, really fast, and you don't want your checkout page to break when Stripe fixes a bug. The second part that's really hard is this cross-origin anonymous thing. This means that this whole system only works if CORS headers are properly set up. CORS headers are awesome, right? Who loves CORS headers? When you're debugging a website, I built this handy flowchart for what to do when your website is broken. And it's always one of these two things, right? It's either DNS or it's CORS. So you're like, all right, you check DNS, and DNS is working. So you look at all the CORS headers, and those are working. Well, then we go back and we check DNS again, because it's definitely one of these two things. CORS breaks all the time for all kinds of weird, unpredictable ways. And I know that because I run an error monitoring company, and I see how often errors happen because of misconfigured CORS headers or weird proxies that just strip them off for no apparent reason. So my conclusion is that this all sucks. CSP is great, but it's hard. Sub-resource integrity is great, but like there's two really big edge cases. And both of these things are just really hard to do. And so I've been playing with some ideas on how to do it. And it's not bulletproof, and we're very prototype kind of figuring stuff out. But I've been working on a better way, hopefully, for how to do this. So I was thinking, OK, I have this website. And it's really important to me that it works good. And I want to know if I get hacked. Now, I don't want to like necessarily stop everybody from accessing it, because chances are, like 99 times out of 100, when something changes on the website, it's fine. I didn't really get hacked. Marketing changed something. Or I changed something and forgot to update my policy or whatever. I just want to know when something changes. And I could do that by putting a little bit of JavaScript on that page. What if I put a little bit of JavaScript on the page, and all that JavaScript did is look at all the other JavaScript and ask, what is it doing? And I know we have a JavaScript problem here, and so let's fix it, and let's just throw more JavaScript on this pile. And I know that this is kind of fundamentally dumb, right? We should fix this problem with content security policy. But as the market has kind of like deemed out, that's too hard and we don't do it. So maybe we can do it an easier way, even if it is a less bulletproof way. So we have this JavaScript, and all this JavaScript does is it looks at the other JavaScript and it says, hey, other JavaScript, where did you come from? And there's pretty well-established and well-supported APIs to find all of this stuff out. So my agent can go in on the site and say, hey, here's a bunch of JavaScript that you have running on your page right now and what domains it came from. And I also know all of these other things that you loaded and where it came from. I can trace the source of it. Not only can I tell you that this is JavaScript running on the page, but this JavaScript came because the developers put a script tag on the page that was served from the server. But this JavaScript came down because Google Tag Manager injected this dynamically on the page. There's APIs that I can use to detect this. So I could build a report that says, hey, here's this cool thing. Here's all the JavaScript you run. And when something new pops up, here's where it came from and what domains it goes to. And I think that's kind of interesting. So if something comes along, like a keylogger, and starts sending data, I don't necessarily want to come down hard on it and turn it off, because chances are it's fine, it's just a pixel that my marketing team added. But I could also look at, say, all right, what kind of data am I sending to different places? Utilizing monkey patching, which I showed you earlier, I could override fetch. Well, I can do that for good reasons in addition to bad reasons. I can patch over fetch and be like, hey, what kind of data is going to all these third parties? And is there data that looks like a name, or a credit card number, or an email address, or a phone number, or anything else that's kind of sensitive? And I could flag it and say, hey, here's the different kinds of data and where they're going. So that when something comes up, this is just an idea of what could exist. I could put all this data together into this JavaScript security report of, here is the JavaScript that you are trusting to run on your page. As of right now, as of today, the users that are running your page, here's the JavaScript that you're running. Here's the domains that they're coming from, the source of how that got on your page, and maybe a risk profile of that domain. Do we think that domain is scary? Do we trust Google Tag Manager? Probably. As you might have guessed, I don't particularly like Google Tag Manager, but I guess I begrudgingly trust Google Tag Manager. But marketingpixels.com, I definitely don't trust that. So I want to know what's going on. So we can count up a bunch of cool things about what domains are we sending stuff to, how much data, or how many times does it run for how many users. And I could do the same thing for the data leaving my system. I could track the number of requests going to different domains, what domains are receiving data from my users, and what kinds of data. So which domains are getting email addresses? How many have they gotten so far? How many users has this run across? And I think this approach is interesting because we're not going to necessarily stop development. We're not going to break our page in order to guarantee security, but we can respond quickly. We would have the tool to be like, hey, here's a thing that is new, and I don't recognize it. And maybe I stomp it out by implementing a quick content security policy and locking it down, but this would be a cool way to know about it. None of this is real. This is just me thinking about it. I've been working on a thing for a little while now called request metrics to monitor a bunch of stuff about the client side. And I have all of this data. I don't do anything security-wise with it yet, but I think it's cool. And I think I could project a really interesting security idea from it. And that's what I kind of wanted to talk about and see what you all had to think about it, if you had any ideas. Because I'm really just trying to play in the security space and see if this makes any sense to anybody other than me, which it probably doesn't, but that's OK, because I write a lot of JavaScript. So today, I think we're wrapping up. I showed you some ways we can attack with JavaScript, some boring ones that get used a lot, and some fun, exciting ones that are kind of terrifying, some vectors to inject it, and then some ways to protect it. And I hope you got something out of this. I hope you have some ideas. If your mind is running and you have some ideas on other exploits that I didn't talk about or some other crazy idea, I'd love to chat with you afterwards, either now or at the bar or at the game show later. Either way, I'd love to talk to you. Thank you so much for coming. This was Hostile JavaScript. I got some cards and stickers up here if you'd like any before you leave. Thank you so much.